So we are going to talk about the ransomware. I'm going to present, this is Arman. I'm going to present with Ocean, Yusuf, and Danush. So at the beginning, I wanna just talk about the ransomware detection algorithms. So for this part, for ransomware detection, as detection algorithms, as defining as the local statistics, local dynamic, and network based, which the information is extracted from the malware binary before it runs and can be obtained before launching the malware. And also the local dynamic, the data is extracted while the program is running based on the actions it takes on the infected computers. And for the network based, the infection comes from the network traffic created by running malware. For all these algorithms, which is the detection algorithm, and this is, and also the other one is the detection general characteristics, which is the combination techniques, and it has a combination of the subset parameter, include the local statistics, local static, local dynamic, and network based, and this parameter to provide a numerical measure of the software dynamic activities. For example, we have the example of the SSD, which is investigated the special behavior of the SSD, where the data were not deleted when overwritten, they were deleted later on a garbage collection action, which is suggested including introducing the SSD in SSD, the measure of the read and rewrite and deletion requests. Also, we have the other machine learning based proposal, which is the technique differ from the combinatorial method because they typically use the much larger number of input parameters, a combination of them, and automatic trading procedure for computing the weight in the combination. And also the ad hoc proposal, which the proposal of the studies in this section use the knowledge of a specific behavior in ransomware sample and are valid only for a few ransomware families, which is in some cases they measure sufficient software characteristics to take into account different behaviors, such as the Android operating system, which is transforming the Java bytecode into formal models and constructing temporal logic properties to describe the characteristics behavior of the ransomware.
Thank you, Arman. So this part, we're talking about machine learning based proposal. Machine learning is like a method of training the computer to look for behaviors such as CPU, disk read and write, and most of the because the machine learning could handle a lot of input that can process the system. It's widely used to help speed up the process. And this article talk about 3 methods of machine learning. So machine learning, it's a supervised technique, and then it also the second one is a support vector machine learning, and then the V detector. So machine learning is just monitor the actions such as folder listing, file read, rename, write, and file entropy in operation. It also checks the disk performance, and the training part of machine learning could occur offline for the system to monitor the good software and then the malware software in a virtual or sandbox environment. That way, we could detect what the malware or the standard system is doing, like such as the window API call, the registry operation, newly created file, the string of the binary that's being used on these offline monitoring. With machine learning support vector machine, it's a linear. It's kind of monitor the network connectivity, see what the system is doing to if there's a malware or ransomware on it, it'll generate a lot of heavy traffic on the networks. Would read detector, that's like the opposite of monitor how the system works. This is just kind of monitor how the ransomware is doing, what processes is using. So these are the machine learning that the auto talk about. And also we also use machine learning to monitor the hardware performance to make sure that the processors running at not 100%, the frequency of the machine, the hardware being used in normal operation, and also if the file, if the system is affected by ransomware, such as high encryption activity on the CPU. Next slide. So with the ad hoc proposal, the author suggests like, look for the behavior of the characteristic of the ransomware, employ a honeypot file or canary file, like fake file, just to see if there's any activity that's running on the system. If there's a ransomware on the system, it'll write to these fake files, and you know the system is infected. And we also talk about if we could block the communication from the ransomware to connect to the command and control server, which kind of give command on the ransomware what to do. So if we could block that connection, that will totally just stop the ransomware, and then monitor the DNS request, or just block those DNS from the blacklist on your firewall. So some of the software that we could use to detect ransomware is like commercial software like CrowdStrike, Managed Engine, SpinOne, TrackLocker, and CryptoStopper. I'll pass it on to my next colleague.
Hi guys, my name is Yusuf, and I'm going to talk a little bit today about file recovery and how we can use it in the case of a ransomware attack to prevent further damage. So file recovery techniques are a great way to safeguard your data, and there's a couple ways we're going to talk about today. The first one is going to be having backups of your data, whether that be via an on-premise solution or a cloud solution. And the second one is using a decryption tool if an attack has already been instigated. These are great solutions, as you're going to be able to hypothetically regain access to your information without paying ransom to the attacker. Now, before I get into the details, I'm going to talk a little bit about when file recovery will not work effectively. So if your ransomware detection has failed and you're not aware that a ransomware attack has already been initiated, first of all, your backups might be also compromised, which renders them useless. And second of all, your data might be encrypted with an encryption key that's going to be difficult to obtain. The next kind of risk with file recovery is that if your backups are infrequently performed, or if they're stored improperly. And lastly, we're going to talk about if your decryption key cannot be located, it's going to be difficult to decrypt your information. Moving on to the next slide here with cryptographic recovery. So this is a great way to gain hold of your data without the use of backups. So there's two ways you can get the decryption key for your data. The first is to investigate your key management system's monitoring to see if the key has been sent to or from your servers. Second of all, there's tools like the No More Ransom Project, which is a great website that provides tips and tricks on ransomware attacks. And it also has a great database of decryption tools that have already been used in previous attacks, very similar to how definitions are used in antivirus. So this is a great way to get a hold of decryption keys after an attack has occurred and hopefully regain your data. Next item we'll talk about is backup recoveries. There are a lot of pros and cons to this. I'll start with the first pro, which is that it can provide up-to-date copies of your protected files. Now, looking to the right, it can also be a con at the same time, depending on the frequency of your backups. If your last backup was 6 months ago and you have critical data, you're not going to have access to it, unfortunately. So making sure the frequency of your backups is very important. Another pro of it is that if you do it securely, you can actually regain access to all your information pretty easily and effectively. It can be done via an on-premise solution, or you can provide get a cloud provider who can do the backups for you. And if combined with a ransomware detection tool, it can be a very effective solution to shutting down your backups and immediately securing them so that you have access to them. Now, talking about the cons a little bit is that it might not contain the most up-to-date data depending on your frequency of backups. Re-implementing those backups and recovery can be very costly for organization and cause a lot of downtime. And lastly, if there's any issues with your backups, such as corruption or file loss, that can also pose a risk to the organization.
I'll talk about the detection and performance results that come with monitoring these ransomware softwares. So the studies put forth a trade-off between the detection percentage and the performance, the loss in performance that comes with such a detection software. So the table on the paper basically shows us an exploded view of the different trade-offs that we'd need to go through in case if the detection rate was high, it would definitely have an impact on our resources. And when I say resources, I mean on the CPU and on the disk storage. So why this performance would have an impact is because if this detection software is something that we're running on our PC in the background, that will take away a chunk of our CPU load average. And if we're using it in combination with file recovery methods that Yusuf talked about, we will also be using up a lot of the disk space. So these are some things that we'll need to leverage when looking at these results. So just the detection rate alone does not provide a fair comparison, as there's multiple factors that come into play here, because also the ransomware samples that were considered during these studies were also varying by a lot, both in the amount of ransomware samples that were taken, as well as the number of benign applications that were provided alongside it in order to detect false positives. And that brings me to my the second factor, which is false positives. So false positives show us, basically tell us how this detection software can also detect any benign software as a ransomware. And this is better than the detection software letting some a dangerous application pass through, but it also is a loss of time for the user if it keeps coming up with false positives. It's a break in the user's workload. And again, like it mentions, a higher false positive rate will disrupt work, which is also a caveat in this study. Let's move on to the next slide. So another factor that comes in here is lost files. So lost files usually occurs when the detection software hasn't detected the ransomware attack yet, but once the files start getting encrypted, if it's using a monitoring, if it's awaiting a monitoring action, then the ransomware might have already begun its attack. And during this window, we might end up losing a couple of files. So that's where, so these studies also bring up lost files. And there's a couple of studies that also say that also claim they've lost zero files. So from the data that the paper has presented us, we've talked about the factors that we can take out of these detection algorithms, the input data that it requires, and the data that it lets us use as factors to contribute to the detection rate, false positives, detection time, the lost files, the impact on resources that it has, and the number of, and also the input data that we've given it, which is the ransomware samples or the families or the benign applications that have been supplied, ransomware detection algorithms based on input, but also we've looked at we've looked at a combination of file recovery methods that talk about scheduled backups of these files. So in a case where these files do end up getting encrypted, we have a quick point of quick point of recovery where we have automatic backup scheduled